Welcome. Thanks for joining us today. I'm Emily Timpey, and I'll be facilitating today's webinar. During today's presentation, attendees will be in listen-only mode. If you experience technical problems, please use the questions pane of the GoToWebinar control panel. I'll be monitoring that area, especially during the start of the presentation today, so I can offer assistance if you need it. You may also use the questions pane at any time during today's presentation to ask questions you may have during the talk. Questions will be addressed at the end of each speaker. So we are pleased to have Brian Fuchs with us today. Brian Fuchs is a faculty member and climatologist for the National Drought Mitigation Center, which is housed within the School of Natural Resources at the University of Nebraska in Lincoln. Brian first came to the School of Natural Resources in May of 2000, working as a regional climatologist for the High Plains Regional Climate Center. He started working with the National Drought Mitigation Center in December 2005. Brian's work is focused on drought-related issues and research projects in both the United States and internationally. The drought-related work concentrates on research involving mitigation, risk assessment, monitoring, impact, and reporting of drought. As a climatologist, Brian works on various applied research projects for the National Drought Mitigation Center, as well as authoring the United States Drought Monitor and the North American Drought Monitor, along with several others. This work helps others to better understand the impacts related to drought across a diverse group of industries from agriculture, energy, tourism, transportation, as well as social and environmental concerns. So Brian, whenever you're ready.
All right, good afternoon, everyone, and I appreciate the invitation to be part of your webinar series. Again, I have presented in the past, and it's always good to touch base with everyone and just talk about what we have going on with the Drought Monitor. And through my presentation, you'll probably hear me say this a lot, but I really see the work with the U.S. Drought Monitor as more of the process we get to go through each week to get to the map, and not really focusing on the end product of the map. But I think there's a lot of good collaboration that goes on, multi-agency, multi-sector, that we get together each week and we do a lot of good things to get this national product off the ground and out to the public. And so what I'll do is I'll go through my talk, and if you have some questions, jot them down or put them in the chat window, and we'll try to address as many of those as we can at the very end. And I'll also have my contact information up at the end. If you'd like to touch base with me offline, I'd welcome that email or phone call and to have that conversation at that time. So as Emily said, my name is Brian Fuchs. I'm with the National Drought Mitigation Center. We're at the University of Nebraska in Lincoln and housed within the School of Natural Resources. Within our group, transition slide, there we go, slide number 2. When the Drought Mitigation Center started, we had a mission statement that was developed. And the mission of our group has pretty much stayed the same from that first year to what we do presently. And almost everything that we do falls within this realm of to lessen societal vulnerability to drought by promoting planning and the adaptation of appropriate risk management techniques. Planning and risk management are highlighted in that mission statement because much of what we do falls into those two realms, and the drought monitoring work really falls into risk management, but we also tie it back into planning with a lot of the work that goes on. So when we start talking about drought, what we find out is a lot of times people's perspective on what drought is really is based on what sector or field that they come from. And we can have conceptual definitions of drought and operational definitions of drought. And if I would survey all of you on the phone and said, hey, write down in a few sentences what you think drought is, I'm going to come back with some similar answers, but I'm also going to know they're going to vary quite differently based on experiences and backgrounds. And so what we typically see is drought is some kind of precipitation deficiency over a period of time. Depending on where you're at, that period of time can be shorter or longer. And sometimes you're looking at drought on water availability or a certain environmental sector. And those are all correct. When we start thinking about drought, it does become complex because a lot of times drought is being defined by the various impacts associated with it. So that's where we come up with the ideas of meteorological, hydrological, agricultural, ecological, and socioeconomic types of drought, because all those are based on the sectors that are being impacted. A lot of times we talk about drought as a creeping phenomena. Unlike other natural disasters where we have the event, we assess it, we start to rebuild or learn from it, drought typically moves a lot slower than our hurricanes, tornadoes, earthquakes, and floods. And that it also is part of the natural climate of any region. Through the data that we have available to us, and also looking at proxy data through tree rings and ice cores and whatnot, we can go back and look over time that almost every part of the globe has been impacted by drought at one point in time. Some areas are more frequently impacted by drought, but no area is totally immune from drought. And we've seen drought in tropical rainforest, and we've seen drought in the desert. So when you think about the definition of drought and what it means for that region, again, it's really dictated by the region that you're in and what type of impacts are being experienced. So going into the drought monitoring aspect of this, and really what the Drought Monitor is, we have examples that go back in time, and this chart that I'm showing is from the U.S. Department of Agriculture back in the 1930s, as they were trying to relay drought conditions for the country based on crop conditions and what kind of impacts they were seeing in production for that year. So this came out in August of 1934, really in the middle of the Dust Bowl era, and you can see what the USDA was trying to do back then was showing where crops were very poor, where it was severely dry, and you can see out west water supply was low, and only a couple areas of the country in the southeast and the Pacific Northwest were average or above as far as crop conditions were going at that time of the year. So going back to what USDA was doing clear back in the 30s, there's always been this attempt to try and classify drought based on what we were seeing on the ground. And that's where the United States Drought Monitor comes in. The U.S. Drought Monitor came about because we were looking for a way to best show and assess drought on a periodic basis. And several ideas came together. I know my colleague Mark Svoboda here at the NDMC and Doug Lecomte, who has since retired, but he was with the Climate Prediction Center. They kind of had some ideas together, and Mark went out to DC in 1999 and sat down with Doug, and after a couple of days they kind of took both their sets of ideas and combined them into what would become the U.S. Drought Monitor. And what is unique about the Drought Monitor is it is a multi-agency effort that the NDMC along with NOAA and USDA are three equal partners who come together each week providing resources and the folks that are behind the authoring of the map to come together each week and do an assessment of what drought conditions look like at any particular point in time. It's a quite popular product. In a typical year where we may not see a lot of drought, we're seeing anywhere from 12.5 to 14 million hits to the web page each year. In times of significant drought like what we saw in 2012, where a big chunk of the country was being impacted by some severe drought, those web hits approached 20 million during that calendar year. And what has been kind of unique for me as I watch these drought events over time, and in my time with the Drought Mitigation Center, is they have steadily climbed. You know, a decade ago, we were probably at 5.5, 6 million hits a year, so we've easily seen that double over time. The U.S. Drought Monitor is used in several USDA programs for relief, and we'll talk about that towards the end. It's also used by the IRS for tax deferrals for livestock producers, and many others are using the U.S. Drought Monitor as a triggering mechanism for their particular state drought plans or emergency management situations, or even individual producers are using it at the farm or ranch level to keep their operations viable in times of drought. So on the U.S. Drought Monitor webpage, it's more than just the main map. A lot of times that's what people come in and they want to see. They want to see the national map, regional or state level map. But as I highlighted in the various drop-down tabs across the top, there are some very popular products, and most of these products have been developed from requests through the public or stakeholders who are using these data. And some of the most popular ones I have highlighted with the stars. I'm not going to go through each one of those. But what you can see is there's a lot of different data available. Users can go in and download these data. If they're into GIS, there's a whole section on GIS data where they can get the shape files and associated statistics. And there are a lot of different options available through this web portal that is the home of the Drought Monitor. So currently, like I said, the Drought Monitor started in 1999. We have 11 current authors, and we also have 2 legacy authors. The last group to come on board was Dave Simmerall at the Western Regional Climate Center, who came on in 2008. And what we also have is this Drought Monitor email list server. And currently we're right at over 450 what I call local experts or validators who participate in the making of the map each week. And they're a big part of this process. They provide information on what's going on locally to their part of the country or their sector. And they also back that up with data or information. As one of the U.S. Drought Monitor authors, a lot of times we are looking at very broad scale national conditions, and what these local experts do is they help to dial us in to maybe some unique situations that the data may or may not be picking up as strongly, but also relaying what the impacts are. And all these people have come together since 1999 to put together this weekly assessment of drought. And as you can see on the graphic here, back in August of 1999, it was experimental, and you can really see how broad brushed some of these areas are, and even the look and feel of the map has changed quite a bit since the original map came out. And so how did the original map come out? There was a drought going on in the summer of 1999 over the Washington, D.C. area, and you can see on that map we had D3 designated in the Beltway and the Mid-Atlantic. And a lot of the decision makers in Washington were wondering, what does this drought mean? And so the Drought Monitor was born. It was presented to those decision makers and stakeholders in DC, and they said they liked it. They liked how it was a single map, how all the different information was coming together. They liked it so much, they said, you're going to do this weekly, you're going to start in a month, and we're not going to give you a budget to do it. And that's kind of continued since 1999. There isn't a budget to do the Drought Monitor. Basically, all the resources are in-kind contributions by NOAA, USDA, and NDMC to come together to get this off the ground and put it out each week. So this is the latest U.S. Drought Monitor that came out in November 28th. I guess we did have a new map that came out on the 5th that I didn't update on the slide. But basically, there's a lot that goes on with these maps. We see the different colors that are showing the drought intensities. The D1 through D4 are considered the 4 drought levels. Abnormally dry, the D0 category is showing areas that are either coming into drought or coming out of drought with some lingering issues that still warrant it being designated on the map. We also have the labels. And so what you'll see are the S's and L's, or the combinations of SL. And what that means is the S's are for short-term drought. Typically on a time scale, the majority of indicators are associated with this drought at a time scale of 6 months or less. The long-term droughts are anything that are 6 months and greater. In some of the western areas, that can go out to several years. And you may have an area like in southern Arizona that's a combination of both S and L. So what you're seeing is both short and long-term dryness and associated impacts at those various time frames. We also tried to designate all the drought areas with a label of some sort where users can get a better feel. Are we looking at short-term, long-term, or a combination of both with those labels on the map? One of the features that is a couple years old here with the Drought Monitor are these change maps. And using GIS technology, what we're able to do is look at various different time frames. So what I have up is just a 1-week change map, and that is showing what we had for changes between 1 week to the next. And so the yellows, browns, and oranges are showing degradation, while the greens and blues are showing improvement. So during this 1 week period, in the Southern Plains region, we're seeing almost all these areas had in yellow a 1-class degradation just in that 1 week. And this is actually a pretty active week with a lot of degradation being shown. And another time frame you can look at is a 2-month time frame. And again, this is looking for the entire country. And we can see the degradation in the lower Mississippi River Valley, in the Southern Plains, and even in the Four Corners region, that just over those 2 months, a lot of areas were drying out and seeing issues developing. And on the flip side, you can see the greens and darker greens in the Northern Plains, the Pacific Northwest, Northern Rockies, and along the Midwest into New England, where those areas were showing improvement during that same time frame. So I like the change maps in a way that I can look at some of these areas quickly and get a better feel for what's happening in just a few clicks of the mouse. There are many different regional maps available too. The national map, of course, is really the launching pad where you can drill down to get the regional or state level maps. You can also look at it by HUC on the various watersheds that are available. We've recently added the USDA Climate Hub regions. We have all the NOAA Regional Climate Center regions. And we've also been investigating, looking at producing the drought monitor for each WFO region. So here's an opportunity for some feedback on that. If you'd like to see the drought monitor for each one of your WFO regions or other regions that we maybe don't show, that feedback is good to hear, and it's not too difficult to add these maps into not only the weekly production, but also build the historical information up as well. One of the most used tools on the Drought Monitor webpage is this weekly comparison. So I'm able to pull up any 2 time periods going all the way back to 2000 to the beginning of the Drought Monitor and do this week-to-week comparison. And then the statistical table that goes along with these comparisons just really shows what that 1 week change, or the difference between the 2 weeks that you're showing, what that change is. And so you can see on this example that there was almost a 15% increase in drought, or the D1 through D4 level of drought in Texas during this 1 week period, which is quite significant. Like I said, drought's typically a creeping, slow-moving type of phenomena, and to see a 15% increase in a single week, that really tells us, gives a little perspective and context to what's going on. So just some of the objectives of the U.S. Drought Monitor. Sometimes a lot of this is just assume that our users know and our participants know, but it's really good to have some of these reminders come out every once in a while. So the Drought Monitor is an assessment of current conditions and current impacts. It's not a forecast that's looking forward. It's not taking into account any of the forecast products either. What we're saying is at this point in time, this is what the conditions and impacts are for any particular area or across the U.S. The Drought Monitor map is not a model either. Sometimes people have called up and said, hey, I want to know what the code is because I want to produce a drought monitor as well. And what we explain to them that it isn't a model. It's not a equation or formula that we're punching in data and it's spitting out a map. That all this is done manually, where the author is again looking at all the different data, which I'll get into in a few slides, but we're moving those impact lines and those drought intensity lines based on the changes that we're seeing week to week and the data supporting it. The U.S. Drought Monitor is not just interpreting precipitation. A lot of times I have stakeholders and users call up and say, well, we've been wetter here, we've been drier here, your map's not right. And what I try to share with them is the Drought Monitor is not trying to just interpret where it has rained or hasn't rained. There are many other products out there that do that, from the regional climate centers through the multi-sensor precipitation products coming from the Weather Service and the River Forecast Centers. And the Drought Monitor, yes, it's taking into account precipitation, but it's not trying to replicate where it has or has not rained. Again, the Drought Monitor is not a forecast or a drought declaration. In most states, the governor is the only one who can declare drought for their state, but decision makers can use it in this way or use it in their decision-making process. And so that does go into some of the state drought plans that are out there. I talked about identifying the impacts on the short and long term, and even these have changed over time. We used to have impacts that said ag and hydro instead of short and long. There also used to be a fire impact, but over time we realized that some of these impacts didn't make sense all the time through all the seasons, and some of them were changed, and some of them, like the fire, were actually eliminated. We incorporate local expert input. Again, this is through that email list server and the Drought Monitor discussion group. And we try to incorporate this because we know that the authors cannot always know exactly what's going on everywhere. And we really rely on people to validate what the data are showing, or even bring up areas where the data may be lagging in terms of impacts being observed on the ground. We as authors, we try to be as objective as possible, and we use the percentile ranking methodology, which I'll get into. The physical data and indicators must support the depiction on the map. That means that when I'm doing the map and my name's on it, at the end of the day, I have the final call. But if anyone calls me up and says, hey, I need to know why you made the decision that you made to keep D2, D3, et cetera, in an area, I need to be able to support that decision with data, with impact information. I just can't say, well, because, but it does have to be supportive. And as far as being objective, none of the authors get any bonus for showing more drought or less drought. That we know that we have to look at everything that we are analyzing in an objective way, because it has to make sense scientifically. And what we do is the convergence of evidence approach. And that allows us to look at all these different data and bring it together into a single map. So what is this convergence of evidence? This is the idea that we can look at many types of data and information, and we try to get the story of what those data are telling us. I try to relay it a lot of times to a trial, where a lawyer will present his or her information to the jury, and the jury has to come up with the solution. Well, in this sense, the Drought Monitor author is the jury, and we collect some of our own information, but also the stakeholders and users that are part of the process, they provide a lot of information to us as well. And so we got to take that information and narrow it down to figure out what is the story that the data are telling us. We also don't cherry pick data, meaning that we need to look at 100% of the data available, but we don't believe in any one piece of the data input making all the decisions. So we don't go through and say, oh, you know, this indicator is the worst that we're seeing out there, and it maybe is in a D3 or D4 area or range. And we wouldn't want to just base a D3 or D4 decision on a single piece of information. Again, we are looking at where all those data streams are pointing to. What's the convergence when we start looking at all of them? What are the majority of those indicators saying? And that's how we come up with those drought intensity levels. We use, again, multiple indicators. They have various periods of records. Some of the newer data, definitely with the satellite tools, have even short periods of record, but a lot of times they're being used in a way that can fill in where we don't have in situ data on the ground. And again, you keep hearing me say or talk about impacts being the ground truth. Yet they really aren't monitored to the extent that some of the other data are that we use, and you really can't measure what you don't monitor. So we really need to do a better job of collecting and cataloging these drought-related impacts, so we know what does drought mean to a region when we see those impacts developing. So this convergence of evidence is all based off of this percentile methodology. Some of the advantages of using the percentiles is it can be applied to any parameter for any period of record, and it puts it into a historical perspective. So how many times has this happened over a given period of time? So what we do is we have all these different data that are collected, and a lot of it is point data. And so what you can do is you can take those values on the point data and you can rank them from the driest to wettest readings or the lowest to the highest readings, and you can break them into these different percentiles, which in turn correlate directly to the DX levels or drought intensity levels on the US Drought Monitor map. So how do we look at these percentiles? So here's just a quick example of what the percentile ranking looks like. So you have 100 years of precipitation data here. And in this example, the lowest reading was in 2012 and the greatest reading was in 2007. And you see quite the spread in the spectrum between the lowest and highest. And what does that mean? Well, this is how we can correlate it to the drought monitor intensity levels. That out of this 100 years of record to be D4, you're only looking at those two values in 2012 and 1940. That's the first and second percentile. And then what you can do is you can look at the D3 levels, or the top 3 to 5 percentile, and that's going to pick up just 3 more years. And so then when you start looking at severe drought, you're picking up 5 more events. And so for D2 through D4, out of 100 years of data, to get into that D2 to D4 range, you're only looking at a top 10 type of event for that region, for that particular indicator. To make it on the map as drought, we pick up the moderate drought levels in the 11th through 20th percentile, so 10 more years get added. And then just to get on the drought monitor map, you pick up those 21st to 30th percentile readings, or 10 more events. So what this really does a good job of showing is the majority of the time you're going to be near normal or not being depicted on the map, because the majority of your data, those 70 other blue dots, fall in that near normal range, where for the drought monitor, we are really focused on the dry side of that distribution, those rare occurrences where drought is being depicted. And realistically, that's only showing up in 20% of the time based on 100 years of record. And again, you could take this could be a 50-year example. And what you're seeing is the longer the period of record, the more examples we have to deal with, and the percentiles become stronger with more data. So when you start looking at these drought areas over time, using these drought monitor time series, and you're looking at Texas as a state as a whole, and then zoomed into a significant event down in Texas in 2011 into 2012, you can see that there are some peaks and valleys in the drought of the region. And if you pull up different areas, you're going to see different time series. But what is nice about the percentile rankings is human nature really recalls the last time the drought was bad. And so if you ask people in Texas, hey, when was the last bad drought? A lot of them would probably come back and say, well, the last bad drought and even the worst drought we've had was in 2011 and 2012. And a lot of times the data may show that, yeah, that was one of the worst areas or worst periods of time that we've seen drought, but it may not have been the worst. And so it takes away that anecdotal or subjectivity that humans have to say that the last one was the worst one. It may in fact be that way, but over time we may see that there were periods that were similar or even worse when we start looking at all the data. Something new that has been developed here more recently has been these new drought monitor maps in Spanish. So from the main drought monitor page, the tab to the far right that I have circled in red there is a Spanish section that is developing, and you are able to start looking at some of these maps here in Spanish. And this is really to better serve some of our Spanish speaking stakeholders and constituents out there that can get more utility out of a map that's in their native language. And so we're still developing this. This has been in conjunction with some of our work with USDA, and slowly we're going to see more and more of these Spanish related products and tools coming out on the Drought Monitor page. So I've talked a lot about the process and how we look at the data, but I really haven't touched on yet how all this is done. So I mentioned that we have 11 authors for the U.S. Drought Monitor currently. 3 of them are at the Climate Prediction Center in Washington, D.C. 2 of them are at the Office of Chief Economist with USDA in Washington, D.C. 3 of them are in Asheville at NCEI. We have 2 of us in Lincoln, myself and Deborah Bathke. And then we also have David Simmerall out at Desert Research Institute with the Western Regional Climate Center. So this is where our 11 authors are located. To be an author, you must work at a regional or national center, government or academia or research area. And again, we are all volunteers. We volunteer our time to do our shifts on the Drought Monitor throughout the year. In a typical year, each author will do 3 to 4 shifts, and a shift is doing 2 weeks and then passing it on to the next author, and they'll do 2 weeks and so on. So all the different data that goes into the Drought Monitor is quite complex. We do not provide any of the input data ourselves through the Drought Mitigation Center. Some of the other agencies do have some data, but what I call ourselves as Drought Monitor authors is we are big data users. So we are relying on these national feeds and regional feeds of data that are coming from various groups and using that data to do the Drought Monitor each week. So we're looking at drought indices, we're looking at soil moisture, stream flow and reservoir, well levels, remote sensing data, expert local input and impact data, precipitation and snowfall, as well as many others. So in the beginning of the Drought Monitor, we actually only had about 4 or 5 data streams that were updated every week and could be used operationally. And that was back in 1999 and the early parts of 2000. Since that time, we have seen technology develop and also the ability of some of these data to be transmitted and updated on a more frequent basis. And so going from 4 to 5 inputs, now we're using 40 to 50 unique indicators each week, and we continue to see this grow. And then the area that we're really seeing this grow is by some of those data providers putting this information right into GIS compatible data, so we can bring these into our GIS projects when we are developing the weekly Drought Monitor map. So some of the key indicators that we're looking at, again, the Palmer, the SPI, the SPEI, the KBDI, modeled soil moisture data from NLDAS and CPC and others. We're looking at the 7 and 14 day, even the 28 day stream flow data from USGS. We're looking at precipitation through the ACES system to the regional climate centers, as well as the AHAPS precipitation, and other data coming from state mesonets or regional efforts. Some of the data coming from the NRCS out in Portland through the SCAN and SNOTEL sites. During the growing season, there's some very ag-specific indicators that we're looking at. Some of the newer ones, such as Veg Dry and ESI, are very much helping to fill in some of those gaps that we don't have a tremendously dense network of in situ surface obs coming from. And out in the west, it's a whole different beast where SWASI, reservoir levels, snowpack, and snow water equivalency from the SNOTEL data, and stream flows and lake levels and even groundwater levels play an important part to some of the decision making that goes on out there. Again, the process really is being built upon those that are providing weekly feedback or weekly updates through various systems. What we are seeing is the regional climate centers, the state climate offices, the Weather Service forecast offices, USDA, tribal groups, the COCORAS group, some of the NIDIS pilots, and even some of the state drought task forces are coming together each week to provide information. And some of you may or may not be involved with some of these groups, and there are others out there that, again, to put them all on a list would be too extensive for right now. But what I'm trying to get at is a lot of people come together each week. Again, the author puts his or her name on the map and they have the final say, but they do work with a lot of people. As an author in any given week, I'll typically have anywhere from 100 to 150 emails come across my desk from folks out in the world who are providing input. I'll typically meet with and discuss situations with multiple states and regional groups that are coming together to really try and show the best information, the best drought monitor map they can for that week. So how can anyone participate in this drought monitor process? Well, I mentioned the email list server. That's really the best and quickest way to get involved with the drought monitor process, is to sign up, see the draft maps, reply to the input on those maps, and give data and information to what you're seeing in your respective area. Or if you have a group within your forecast office or River Forecast Center or a regional group that you can work with, those have been developing across the country as well. I know in the Carolinas they have a weekly discussion when drought is an issue. Down in the ACF River Basin and Florida, Georgia, and Alabama, they get together. Texas has a statewide call that gets together every Monday. In Colorado, they have a group that gets together based on their NIDIS dues region. California and Nevada have recently got together on calls when drought is a needed topic to be discussed, and there's others out there. And so there are ample opportunities to become more involved or be part of this process just through participating through the email list or getting involved in one of these state or regional coordination calls. So who is in this Drought Monitor network? We've recently compiled some statistics on the makeup of the Drought Monitor listserver and who these folks are, how long they've been involved, does their job require them to participate, how much time do they spend on their weekly contribution. And so the next slide here, or the slide I'm on, and the next one really talks about some of the responses to this participation in the process of the Drought Monitor. And I'm not going to go through all these other than on this next slide. You can kind of really see that these networks are in action, that some folks are spending up to 6 hours a week on compiling information and sharing it. And everyone's talking about what's going on locally to them. And so that's important because, like I said, and you saw where the authors are, we're not evenly distributed around the country. And we're coming at authoring the Drought Monitor from various backgrounds and expertise. And so we really do rely on our local experts and validators to dial us in and provide information and expertise on what they're seeing in their part of the world. If you're interested in joining the U.S. Drought Monitor listserver, I have circled the email address down in the lower left-hand corner of this slide. You can email that comes to me directly, or you can email me, and I'm going to share my email at the end. I control the email listserver, and I can get you signed up, and we can talk about that offline if you're interested. So shoot me an email if you're not on the list right now and you'd like to join. So over time, the Drought Monitor has become used more and more. Again, we're just completing 17 full years of production now and going into our 18th year. And over that time, the Drought Monitor's track record has been vetted and validated, and independently, different groups have come across and started using the Drought Monitor for their decision-making process. In 2008, the Farm Bill from USDA was the first time that the Drought Monitor was written in to be used as a triggering mechanism for various programs that they have. I mentioned the IRS already, some of the fast-track designations for drought through USDA. The Weather Service has implemented their drought information statements based on the D2 or worse level. EPA is using it, CDC, Bureau of Land Management. Several states are using it as a triggering mechanism for their state level drought plans, and there are many others who are using it as well. Just recently, I talked with Mike Brewer at NCEI, and they had done some work on looking at the Drought Monitor and some of the uses that was being conducted from independent users. And Mike shared these slides with me, and he's going to be presenting some of this information at AMS in January, and a full report will also come out associated with it. But what they're showing is just in livestock farming, $100 billion annually is being associated to economics associated with the Drought Monitor. And the Farm Bill with the livestock forage production program that is directly related to the U.S. Drought Monitor has delivered over $6 billion, close to $7 billion in aid now to livestock producers who have suffered losses and have had relief triggered by the Drought Monitor since the 2008 Farm Bill first initiated that program. And, just for a particular livestock farmer, they're using it on decisions on their cow-calf operations in the plain states, how to manage herd size, how to turn a profit, how to keep from overgrazing. So when we go back a slide and looking at it from the broader spectrum of economics, that you can go all the way down to the micro level of economics, where individual farmers and ranchers are using the Drought Monitor to better inform themselves in their decision-making process. And again, more of this information is going to come out from NCEI here in about a month now after AMS, and the report that goes along with it really digs into some of these numbers and uses, especially in the livestock arena, for the U.S. Drought Monitor. So that's really solidifying the importance of why putting out the best drought monitor, why getting more and more feedback from the field and the participation from the field is needed, because a lot of high dollar decisions are being made on this product. And I, as an author, my goal is to always put out the best information when my name is on that map, and to really support those who are using that product to use it to the best of their ability and in their decision-making process. So what's coming up next down the pike for the Drought Monitor? We're going to continue to work with our partners on data sets and data availability, especially pushing these data sets into some of the automatic data scripting that can be available to the authors, as well as getting new and different data into a GIS format that we can bring right into the weekly Drought Monitor projects. Throughout 2018, we are going to be transitioning the making of the Drought Monitor map to a Esri online portal, where instead of sending information through the email list server and suggestions, a lot of that is going to transition over to this Esri portal, where if you're down in Texas and you have a recommendation, you'll be able to draw right on the map of Texas what you're thinking, and you can provide the supporting data right there. And then as the author, I can go in and say, yes, I accept that change, and make it permanent on the map, and just a little bit more of an interactive way of making the map using the Esri technology that's available. And a lot of the discussions that take place currently through the email list are going to transition to more of what I would call like a web forum, where those discussions can take place right on that Esri portal, where they're going to be not only cataloged and archived, but then people can see, hey, that comments on Arkansas, and I'm up in Vermont. I can just bypass that and not talk about, and not even pay attention to it. So hopefully it helps to streamline some of those emails that we currently have going out to everyone, that you can really focus on what's pertinent to you in that process each week. We also have developed some Drought Monitor tutorials, and the first cut for this tutorial is available online at the URL provided. And basically, as some of these questions come up, we try to address those questions on the Drought Monitor, the process, the data, etc., through these tutorials. So as a forecast office or a river forecast center or other stakeholder, you can again share these tutorials with people who have questions, or post them on your web pages, where people can go and find more information out about the Drought Monitor. Because as we know, as I know in particularly, there's a lot of misinformation that gets floated around on what the Drought Monitor is or isn't. And hopefully this will help to better inform our users and stakeholders, as well as those who participate in the weekly Drought Monitor. For those that are familiar with the Drought Monitor, you've seen these objective blends that have come out through the Climate Prediction Center since about 2002, based on climate division-based data. At the NDMC, we are taking those and transitioning them to a gridded data set, and a much finer resolution than what the old blends are currently being made at. We're going to transition to those this next year. Potential impact tables are being developed for each state based on data that's been collected through the Drought Impact Reporter. And we are also looking at expanding the Drought Monitor to the U.S. Virgin Islands and the U.S. Affiliated Pacific Islands, or USAPI, here in the next year. down in the Virgin Islands, the hurricanes this last fall really set back that effort, and hopefully we can pick that up here in the first part of 2018 as well. There has been some experimental drought monitor products coming out for the US API developed by Richard Heim at NCEI for the last couple years, and hopefully we can get both these going operational in 2018. Finally, 2 more slides. There is this US Drought Monitor brochure. I know with many outreach events that the Weather Service offices do, this may be a good one to print out. It's a front and back trifold handout that we bring to most all of our events. Really just a quick overview of what the Drought Monitor is, what goes into the process each week. This is downloadable right from the Drought Monitor webpage. It's also available in Spanish. And my last slide is this handbook of drought indices and indicators that I put together for the WMO along with Mark Sabota. If you're really interested in digging into some of the data and on drought and different indices and indicators available, this handbook is online. It's in several languages through WMO as well. And it really gives a good overview of the various drought indices that are out there and can be used. I want to acknowledge our partners, everyone from NIDIS to USDA to SCIP to NOAA, University of Nebraska, and at that point in time, I'll put up my contact information. I'll gladly take any questions or go back to any of the slides that I went through if you'd like me to go over something more thoroughly. Thank you.
All right, thanks, Brian. That was a great presentation. So as a reminder to everyone at this time, we will take questions, and you can type your questions in the questions pane of the GoToWebinar control panel. So I'll be monitoring that over the next couple minutes for any questions that come in. So I'll just start off. I know you mentioned about you guys utilizing the COCORA's condition monitoring reports, and I know that initiative has expanded. How heavily are those utilized with those reports coming from a lot of the public?
Yeah, that's a great question. So initially with COCORA's, their observers were actually reporting drought-related impacts, which in turn would feed right into the drought impact reporter. And now with the new system that has been launched across the country with the condition monitoring, what we are doing is, again, those are available in a GIS feed. And so as authors, what we're doing is bringing in those condition monitoring reports, and it's kind of directing our eyes to areas that, if we see an area that has minimal drought or low intensity drought, but we're seeing a lot of condition monitoring reports that are coming in as extremely dry or very dry, it may draw our eyes to that area to kind of dig into the data a little more thoroughly to see if we're missing something. So again, the public with their eyes on the ground and giving their feedback, it does help to push the eyes of the authors to areas that may need to be addressed more thoroughly than what they currently are.
That's great, thanks. So a reminder, I don't see any questions right now within the questions pane, so feel free over the next couple of minutes to send in your questions. So when people put in those reports and that wording, is there anything especially helpful that you guys are looking for, like wording-wise, or do you have any suggestions on specifically what kind of feedback you're looking for?
As far as the impact reports or for the contributions to the weekly production?
Both. If you can comment on both.
Yeah, I'll start with the weekly production. I think a lot of times what we as authors really look at is if someone is providing recommendations, that they provide a context of what they're looking at. So it can really cut down on some of the back and forth if I'm suggesting we're a D2 expansion for counties X, Y, and Z, and I provide the information or support as to why I'm looking for that expansion. A lot of times I'll get, hey, expand D2 into these counties, but nothing is given as to why or what's being observed. And so we will dig into it and get down to the whys and becauses of that change, but a lot of times time can be saved, which is of the essence when you're doing a national map, to have that information provided right up front. Now, when it comes to condition monitoring or impact reports, it really has to be providing some context. some historical context really helps, or sometimes people will provide a photograph and show a burnt up hayfield or cornfield or bean field, or maybe a stream that's dry. And it doesn't really give us any context that, is this unusual that this happens, or this is only the second time in the last 20 years we've seen this happen, where sometimes those details aren't provided. And as an author and trying to make a decision, knowing some kind of historical context to those impacts really helps to give some perspective. And also what we've seen with the drought monitor being used in some of these relief programs, especially the livestock forage production, I have a lot of people calling up or emailing and say, we're D3, and because that means higher payments. Well, they have no idea what D3 means, but they insist that they should be D3. And so a lot of times we need to wade through some of the messages that are coming across our desk as well, just to get an idea of exactly what an area is seeing. And again, we always encourage state or regional coordination, because if there's 10 people reporting for a state and they're giving 10 different viewpoints, we'd rather those 10 people get together, come up with a single solution for that state, or even working with their surrounding states and then providing a single recommendation to the author, just again to save time with that back and forth, or to eliminate the conflicting information before it comes across our desk.
All right, great. That was very helpful. Someone asked how assured the technical accuracy of the Spanish translations are. He said Google Translate doesn't always know the terms to describe specific hydrologic conditions.
Yeah, we have struggled with that. For the weekly Drought Monitor narrative translation, we are working with a translating service. So we are actually paying them to translate the weekly narrative. For the maps, and that pretty much the templates for those are static. And we have worked with some of our Spanish-speaking partners within NOAA and USDA, and also down in Mexico with the North American Drought Monitor, to refine those map templates. But you're exactly right with some of the text. It's not as simple as using Google Translate, I'll say that.
All right, thanks. And we just had one last comment that said, thank you, Brian. What you guys do is amazing.
I appreciate that. That's good to hear.
Okay, well, I'm not seeing any other questions, so I think at this time we'll start wrapping up. So again, thank you, Brian, for the presentation, and thank you for everyone for attending and participating in today's webinar. Give us a few days and we'll have the materials, both the presentation and the recording, posted online. So thanks again for your participation, and this concludes our webinar for today.
Thank you, Emily.